Hello, my name is Lars, and I'm going to talk about what makes laptop computers fail and why you need to consider cooling in any electronic device that's got a wattage going through it in the circuit inside. Now, on my lap here, oops, can you hear my tummy growling? That's the hummus. If you look on my lap, I have a laptop. This happens to be an Apple, but there's quite a difference in the attitude of the laptop makers, actually all device makers, in regards to cooling. And do we want to really become a victim of poor cooling? Because this can end up where all your work gets lost because you have a failure. So, in this laptop, there's absolutely no airflow holes. So if they're lucky enough that there's a cooling fan inside, where are the air ports that it's pulling the air to cool the chips inside? Now it's true that due to Moore's law, that the integration, the curve of is like a effect of you get circuits that run on less power and run faster and are more reliable, but as you progress along the evolution of solid-state circuitry, you end up with some point where maybe the first release of it, or the idea of it, like a CPU, runs very hot. So how do you get? What is the consideration here? Is the computer you bought got a way to keep cool? I mean, is there going to be some chance of failure because of overheating? Do you have to be careful of thermal cycling? I mean, what is inside one of these that'll break? And why does it always seem to break just when the warranty expires? So what they have a lot of times in a modern like laptop device, you'll have like a CPU chip. There might be a socket, or maybe it's directly on the board, but they often use a soldering technique that resembles it's called like a ball grid array chip carrier, and the package of the chips inside are actually arrays of tiny dots of solder called a ball grid array, and they airflow this under high temperature so that the chip is soldered directly to the board. There's no socket. It just usually would just in this case just solder right to the board. And then for good measure, they might beat it with some glue to make sure it holds in case there's a flex to the board. That can happen. You don't want it breaking loose in the board because these are very tiny solder dots. And there might be 400, 500, 1,000 dots under a device like a CPU. But suppose the CPU chip, part of the work is bridged off on bridge chips, and some of the data delivery inside to memory or to the hard drive or to the whatever else you've got going on inside your laptop, the video, you need those chips to buffer the information, and they bridge them, and those chips are even more vulnerable than most like Intel chips. All these chips are pretty tough, especially the CPUs, but the glue chips, the bridge chips, the chips that are necessary to support the functions that you're trying to do, display your pictures or whatever access your hard drive, those are more vulnerable to heat. And some have heat sinks, and a lot of times if you open one up, inside is a massive piece of metal, copper or something, and you get a good airflow or good heat dissipation. The heat sink handles the heat problem. But let's say it's a kind of an older machine, it's a real hot chip. The glue chip is, you're depending on it for video. There has been notorious situations with NVIDIA video chips on laptops. There were a lot of them went bad. Well, so that video would cut out on these laptops, and there was maybe a talk of a class action suit against Hewlett Packard, Dell, and finally they thought, well, let's go after NVIDIA. But pretty much everybody that got that chip in their laptop saw the failure. So there's been a kind of cottage industry of reflowing the solder joints, those ball grid joints, those tiny. Does that help? Sometimes. But that is what is the real problem is in the silicon semiconductor device that is the chip. They have ion problem. We talked about the debilitating effects of heat and the lack of cooling and the limited life of chips. And what is the limited life of chips due to? Well, it's solid state physics. If you have a dopant in the semiconductor to make it semiconducting, and there's like extra ions there, you get what's called an ion migration. And ion migration is where the junction, which is normally an insulated condition, the ions are conductive, and they drift, physically drift, through the space of the crystal inside the semiconductor over time, and they're affected by heat. And you can maybe loosen them back or go back where they started in their migrations by a heat shock. That's why they talk about, well, heat it up and reflow it. But they're not really helping it by resoldering it. What they're really helping is reset the crystal lattice that is the semiconductor, so that the shorting ions are no longer on the junctions, causing transistors to become shorts. So when a chip has got to the end of its life, it's starting to short more often because the migrations are more frequently shorting it out. And where you may have been giving it a stable life of use and a unchanging pattern of use where there wasn't a full thermal cycle, you are like protecting it maybe. And in the case where you start to turn it off and on and off and on, that's the most radical thermal cycling possible, from nothing to the fullest temperature. And you may have to end up where you have it to either get another motherboard or system board, as they prefer outside of Asia to call the board that the system computer runs on, or another internal board for your laptop. And the problem is, if it's an Apple, they want just to open it up and maybe wiggle the wires. That's a $700 flat rate. So if you'd bought a PC instead of an Apple and gone down that road, there would have been cooling holes, because all of the IBM compatible PCs, they can run Linux. They don't have to run Windows. But the ones that are built that way are to show airflow possibilities, and so they might be more opportunity for it to flow. But you're always running the risk in a tightly compact device of having heat problems and maybe being a victim of semiconductor physics and having ion migration shorting out the darn thing. Sorry.
So that's the answer to whether I should turn my computer on and off on a regular basis.
It's kind of an advisory. What you might want to be careful about going down that road. The advice is, you got to turn it off. Something might happen. Well, something might happen if you turn it off.